This is the Linux Command Line Survival Guide for beginners. In this guide, I'm going to cover the most important and most common commands to get you up and running fast. If you learn the commands in this guide, you should have enough info to get by and be competent. This guide is meant to be concise and practical. I'm including as much useful information as possible without making things too complicated or advanced. So I had two types of people in mind when I made this guide. A home or desktop user that's new to Linux and just needs to get a handle on the command line, or a developer or other IT role that needs to be able to log into Linux servers and be somewhat confident and not embarrass yourself. So check the link in the description for copy and paste examples of all of these commands, and also you're going to get a whole lot more info in the guide that I've linked to in the description of this video. So let's just jump right into it. Now, the first three commands that you should learn are ls, pwd, and cd. Now, let's get started with ls. Just type ls, and this is going to give you a listing of the files in the current directory. Now, there's a lot more than what's displayed on the screen here. You can scroll up to see the rest of them. Now, the next thing you're going to want to learn is -l for the long listing format. This is going to give you permissions, the stuff over here, the user, the group, the file size, and the actual file name over here. Now, if you add an H to that, that's going to give you the file sizes in human readable format. See, K, you're going to have bytes, and like this one right here. And if you scroll up enough, there is megs in here too, and G for gigs. So, any case, if you want to see all the files in your directory, just use an A, and you can use any combination of these switches. But if you add an A, that's going to be all files, including hidden files. So files starting with a period are hidden, and they're hidden usually because they just contain config info for an application that you normally don't look at by hand, and you don't want them cluttering up your directory. So you can also say, you can also add a TR. So T to sort by time, and R to do that in reverse. So hit enter, and you will notice that the newest files are on the bottom, and as you scroll up, they get older. So yeah, that's a pretty normal way to sort things. Now, another thing you can do is ls-R for recursive. Now, this will search through everything recursively. So it will show you what subdirectories there are and what's inside those subdirectories. So we're going to do this on the Etsy directory. So if you have Etsy right here, we're just going to search recursively on Etsy so you can see the Etsy directory and the subdirectories inside it and the files inside those subdirectories. Another thing I should quick mention, anytime you use the ls command, you can specify the directory that you want to access, like this. You can specify Etsy like this, or var log like this. You can check the log directory, or you can check a local directory, like one that's right here in my current directory. You can say ls web. You could check the web directory if you want. So another thing, one more thing I want to show you for the ls command is ls-s, capital S, and this will sort by size largest first. So there we go, and that's not very useful unless you have LH there to actually show you the long listing and the actual sizes. So this will show you all of the sizes, starting smallest on the bottom here, and going up, it will show you the largest files at the top. And see, we're using human readable, so it says K when you get to K, and meg when you get to megs. And that is incredibly useful to find like large files that might be eating up all your space. Now, I believe, yes, we can do that by reverse also, so add an R and you're sorting in reverse, showing the largest ones on the bottom. So that's a little bit easier than scrolling up. Now, next command to learn is pwd. pwd will show you where you are currently. So right now, I am logged in as the user1, so I am in home user1. That's the home directory for user1. Now, what you can do, the next command is the cd command. So you can type cd and the name of a directory, like dir1, and that's going to cd into dir1, which doesn't exist yet. So let's cd into web, and then we're going to show where we are with pwd. That's a handy command we're going to be using a lot. And we are in home user1 web. Now, if you type cd again, it will bring you back to your home directory by default. Now, a few quick shortcuts I'm going to show you. So cd by itself will always bring you to your home directory, right? Now, if you run cd tilde, same thing. So tilde is a shortcut for your home directory. You can use that on other places too, but if you don't want to type this, you can just type cd by itself, and by default it brings you there. The tilde is going to be useful in other places besides just the cd command. Now, if you are in here, let's say we're in the web directory, right? Now, if you type cd ... the dots refer to the parent directory. So that's going to bring me up to the parent directory right here. Now, another thing you can do is you can use, you can go up 2 directories like cd ... var log, and that brings me to var log. So that brought me up 2 directories to the root, and then go down into var log. So also you can, as I already showed you, you can cd to full paths like this, var log, and so on. So that's how the cd command works. And also worth mentioning, this will come up later, the dot, so dot is your parent directory, and just 1 dot is the current directory. And obviously tilde is your home directory. So if you said cd dot, that does nothing. There are other places where you do need to use a dot to refer to the current directory. We'll get to that stuff later. Now, another thing I should mention, there are 2 ways to specify paths. You can specify a path with a absolute path like this, so the exact path all the way from the root. So you can do that, or you can say absolute path is like this, or you can specify this with a relative path, which we already looked at, but relative path to, so it's relative to where I am, and another relative path, technically something in the same directory, like web, that's a relative path to the web, which, where am I? Yeah, all right, so in my home directory, web, that's a relative path to the web directory. Anyways, moving along here. So next section, we're going to talk about navigation and getting help. So first thing you should know is the man command. So man is a command that gives you the manual for any other command you specify. So specify the ls command. It's going to give you the manual for the ls command. You can use arrows to scroll down and look at all the options. There's a ton of options. A lot of them you won't use. Some of them are pretty handy. Hit Q to get out of there. Now, another command is an alternate, more detailed for documentations, is the info command. So you can say info ls. This is less common and a lot of people don't like it, but it's an alternative that exists you should know about. So there are the info pages. There's a lot you can do with these, and they're supposed to be linked together and stuff. In any case, man is the most common one. Almost everybody uses man all the time, but it's a quick reference that most people are used to. Now, another command is the help command. Now, if you type help for ls, you're not going to get anything, because help is for built-in commands. So for example, if you say man for cd, no manual entry for cd. So you can use help, since cd is a built-in command, you use help for cd. You can get information about the cd command, but not the ls command, because it's not built in. So man and info for normal commands, and help for built-in commands. Now, there's another command thing I want to show you that's really handy, is the TLDR command. So you can say TLDR and say ls. And this will give you just quick examples and descriptions of how to use this command. So a lot of really useful stuff. Nice, quick, useful, practical thing right here to give you, useful, you can basically use the command with what it shows you right here, and you don't have to read this long man page, right? So the man command gives you these long manual pages. TLDR is too long, didn't read. It will give you the info that you want right there, and it also works for built-in commands like the cd command. Now, you probably won't have the TLDR command installed on your system, so check the link in the description for how to install it. It's pretty easy. I got all the stuff there, but I didn't want to go too into detail in this guide because I'm trying to make this real quick and fast, and make this just a quick guide without, I don't want it to get too complicated. But in any case, yeah, so the next thing I want to show you is the history command. So type history, and this will give you a history of every command that you've typed. So you can scroll up and see what you did in the past. Maybe you forgot how to do something, or you want to reference one of your commands. Maybe you want to copy paste your command, or maybe someone else logged into the system before you. You want to see what they did. Maybe someone installed something or configured something and you don't know how they did it. What did they mess up? Or maybe they know how to do something, or run a command, or launch a server, or use a tool, and they know how to do it and you don't, and maybe they left the company, or you don't have contact with them and you just want to see what they did and how they did it. You can look at what they did. So if you're on an unknown server and you're trying to figure something out, look at the history and see what was done to the server, to see how it was configured and how to do things, and how other people have done things on that server in the past. Now, Sometimes you might be using a shell, or maybe it'll be the standard shell for whatever company you're at, other than Bash, and the history won't give you your full history, only maybe the last 100 commands. In that case, you can say history 0, and that will give you your full history. Now in this case, I'm using normal Bash shell like most distros have, and so history 0 gives me nothing, but the history command gives me all the stuff that I want. Now, you can also type the up arrow, and this will give you the last command that you used. Hit it again, it'll give you the command before that. Keep hitting the up arrow to cycle through, basically to cycle through your history and all the previous commands you ran. Hit enter, and it launches that command. So the up arrow will do that. You can use the up arrow, and you can use the down arrow to go back through them. Now, the other thing to be aware of is tab for completion. So you could say ls, and let's say you say WE, hit tab, and it'll complete it. B for web. So I didn't actually type the B, I just hit tab and it finished typing that out for me. So let's say if I had a longer thing like Z home directory, I could say ls Z underscore, hit tab, and it completes it for me. It's like an autocomplete. So tab is very useful, the up arrow is very useful, history is very useful. Now if you want to go to the home or end of a line, say if you have a command like this, you can use the home button or the end button on most systems. Now if you're logged in remotely through something like PuTTY from a Windows system, some terminals don't work with the home or end buttons, and an alternative is Control A or Control E to jump to the beginning and end of line. So just be aware of that. But most of the time, like if you installed Linux yourself and you're using a terminal on Linux, you can usually just use home and end. Now, next thing I want to show you is the clear command. Say if you have a lot of stuff on your screen, you just type clear, and that will clear your screen. So that's a nice thing too. Now, I'm going to have to show you the cat command. We'll cover this a little bit in more detail later, but if you want to cat a file to see what's in it, you can say cat and then file name, test1.txt, for example. We can see what's in that file. We can say cat web, and see I just tabbed that out to type that, to autocomplete that, but we can see what's in this file right here. And yeah, so the cat command will show you what's inside a text file. You can see what's inside text files with that, so that is nice. Now, next command I'm going to show you is the cp command to copy files. So if you have a file, you can say cp, and it goes source destination. So you can say test1.txt to test2.txt, and this is going to copy that file over. Then the original is still going to exist. It doesn't move it, it just copies it. Now, if you have a directory, I'm going to quick create. I'm going to get to the mkdir command later, but if you have a directory like dir1, that's me creating that directory right there, dir1. So if you want to copy a file into that directory, you can use the same command we used here, except instead of specifying a file, specify a directory. If the destination is a directory, it's going to copy the file into that directory. If the destination is a file, it's going to copy it to that, either creating a new file or it will overwrite an existing file, so be careful for that. So boom, I just copied that into dir1, and we can check what's inside dir1 there. We can see I have a copy of test1 inside there. Now, other things you can do, if you want to preserve permissions, with that same command, anytime you copy something, you use -p. That will preserve like the mode or the permissions on the file, the ownership, and the timestamps. So that's good. For example, if you're like the root or the admin user or something else, and you don't want to change the permissions when you create a copy of a file, you can preserve them like that. If you're copying someone else's files around and you don't want to mess up the permissions with your permissions, you can use the -p. Now, a -r will be recursive. So let's say if we have, let's say dir2, I'm just going to quick create another directory here as an example. Now, we have dir1 and dir2. If you try to copy dir1 into dir2, dir1 into dir2, this will fail. So what you need to do is use a -r, and that will a -r for recursive, and that will allow us to copy dir1 into dir2. Now, we still have dir1 here, but we now have another dir1 inside dir2. So that's how you copy one directory into another. Now, if that directory didn't exist, it would have created a copy of it. So next thing we want to look at is moving files. So if you say mv file, test1.txt to test3.txt, this will move the file. It will overwrite the destination if something's already there. If not, it just moves the file to here. But this is also effectively renaming the file. The original will be gone and the new one will be there. So this is effectively renaming this file to this file, right? So you can move the file like that. Now, if you were to do this with test3, move test3.txt into dir1, you will, if the destination is, so basically you have source, destination. If the destination is a directory, it's just going to move the file into the directory. So dir1, like that, there we go. We got both of those files that we've placed in there. Now, what else? Okay, you can move a directory into another directory or rename it if that directory does not exist. So what do we have here? Dir1. Okay, so I'm going to mkdir dir3, and you can say move dir1 into dir3, and there we go. dir3 now contains dir1. Now if we move dir3 to dir4 doesn't exist. We basically renamed dir3. And there we go, dir4 right there. So the most recent things we've worked on are this stuff right here. Now, real quick, let's talk about the difference between hard links and soft links. Now, a hard link is just an alternate name for a file. So you have the data on disk and you have a name pointing to that file. You can create an alternate name pointing to that same data on file. Those are hard links. Now, if you create a hard link, two hard links to a file or multiple, you need to delete each one of these hard links or each one of these alternate names before the actual file counts as being deleted. Now, a symlink or a soft link or symbolic link is what you see right here on the far left. Now, the symlink points to a hard link or a regular file name, and the file name itself points to the data on disk. So if you create this, if you actually delete this file name and it's the only hard link pointing to the data on disk, that file is gone. The symlink will still be there and it will be a broken link. Now if you just delete the symlink, then the file remains and still points to the data on disk. So most cases, you don't really create hard links that often. They're not used in practice that much, at least for me, from what I've seen. But symlinks are used very commonly just to create an alternate pointer to a file name. So those are very common. Now we're going to show you how to work with those with the ln command. All right, so the ln command creates links. So if we can go like this, let's see if I'm going to create. We have a test2 right here. We're going to create a link to test2. So we can say ln test2.txt, and we can say link1.txt. So we're doing that creates a hard link. So this is the source, this is the destination, this is the actual link, and this is the file you're linking to. Since this is a hard link, we have two of these, and they both point to the same data on disk. You'd have to delete both of them to actually delete the file. So I'm going to remove this for now. And there we go. Now, the other thing you can do is create a symbolic link. So we're going to use that same exact command, but you specify a -x. Now, this is what you want most of the time. This will create a symbolic link. Now, we check right here. We see link 1 that we just created is pointing to test2.txt. Now, you can also link directories. You say ln-s dir1 abc. And okay, we don't have a dir1 anymore. Let's link to dir2. Whoops, and I typed ls. So type ln-s dir2.abc. And yeah, anyways. So here we can see ABC is now a link pointing to dir2. So we say ls abc, and we can see whatever's inside dir2. Now, so you can link to a file, link to a directory. Now you can use a relative path to the file you want to link to. So like this, you can say ln-s and relative path to the source. So this link will only work from where we are. You have to be, this relative path has to be valid. So if I move this link into a subdirectory, it would not work. So we already have a link 3. Let's just call this link 4. All right, link 5. All right, there we go. So link 5 now points to .. etc hosts. Now, We can also use an absolute path. So we could say ln-s and say etc hosts, linking to the same file, but use an absolute path, and we're going to call this link 6. And there we go. Link 6 is pointing to etc hosts. Now, if you were to take this link and move it somewhere else, like into dir2 or dir4, that would still be pointing exactly to etc hosts. But if you moved link 5 into dir2 or dir4, that would not be pointing to etc hosts anymore. It would be only going 2 directories back, not far enough back to go all the way back. Now, one more thing I wanted to show you. You'll notice up here, there's a broken link here. You can tell it's a broken link because it is red. It's pointing to a file that's called doesn't exist.txt. So that file doesn't exist, which is why that's a broken link. So I'm going to show you another way to create a broken. Yeah, let's see here. I'm going to show you another way to create a broken link. If you rm test2.txt, that will create a broken link. So the original file is gone, but the link is still pointing there. That's a broken link, so it's in red. Now, if you were to link to something that doesn't exist, like say ln-s, and create, say, new link2.txt. All right, so that's going to be the link name, but it's going to link to something that doesn't exist. Does not exist.txt. So we're going to link to this file, which doesn't exist. So we're naming it that way so you know. This file links to it. So it does not exist. So it's a broken link, another broken link there. So that's all fine and great. So that pretty much shows you everything you really need to know about links. Next command you really should be aware of is the touch command. So you can create new files by using the touch command. So touch abc.txt will create a new file called abc.txt. Now, if abc.txt already exists, it will just update the current timestamp on that file. So the access and modification times for that file will be updated to the current time every time you touch the file. So touch a file, it just changes the time that it was last modified or accessed. Now, and if it did not exist, it creates a new empty file, just so a file will exist there. So another thing you do is the stat command. So stat etc hosts will give you information about that file etc hosts. So you can see it'll give you the size, the blocks, a bunch of other stuff, the permissions, the user, access and modify times, the change times, and the birth time of the file. So that's etc host. All right, so let's try another command besides the stat command is the file command. So you can say run file on etc hosts, and that will tell you what type of file it is. It's ASCII text, so it's a text file, right? So you can also use the file command on user bin nslookup. So this is a binary file, so it will tell us that. It is an ELF 64-bit LSB Pi executable for, it tells you like the architecture, dynamically linked, and so on and so forth, a bunch of other stuff about the binary. So basically it'll tell you what type of file something is and a bunch of details about the file. So, all right, next thing we are going to learn about is the mkdir command. So moving right along here, let's clear all this out, and we can mkdir. I'm going to clear out all these other directories, and I'm going to show you more about removing things in a bit. But so with that, I'm just wiping out all those directories. I'll show you more about how that works in just a bit. But first, I'm going to show you the mkdir command, mkdir dir3. So this will create a directory called dir3. Now, you can also say mkdir dir1, dir2. Now, since dir1 does not exist right now, it will say can't create the directory because the file does not exist. That means it can't create dir2 because dir1 does not exist. Now, you can, if you want to fix this, because you don't want to use 2 separate commands to create dir1 and dir2, especially if you have multiple different levels to that, it gets to be more of a pain. So you can add a -p to say create any necessary parent files. So -p will basically fix that problem, and it will create dir1 and dir2 inside of it. So great thing to be aware of. So that's everything I want to show you for the mkdir command. Let's move on to the rmdir command. Now you can run rmdir. Rmdir will remove a directory so long as it's empty. So you can rm dir 3, and it removes the directory, totally fine. You could rm dir 1, it won't remove it because it is not empty. But you could specify dir 2 within dir 1, and that will remove dir 2, and now dir 1 is going to be empty. So you can now rm dir 1, and now that's gone too. That's one way to do it, but we're going to show you in just a sec how you can, you know what, I'm going to recreate that. Mk dir-p dir 1 dir 2, and let's place a file in there just for good measure. So touch dir 1 test1.txt. All right, so ls dir 1 has a directory and a file inside it. Now, you can't rm dir that unless you remove the stuff inside it. Now, there is a way around that. You don't want to remove each thing inside it. Directory is not empty, so you can remove it by using the, you can just do an rm, you can use, instead of the rm dir command, because rm dir is only for empty directories, you can use the rm command. The rm command is used for deleting files and directories, and if you do -r, that's going to be recursive, and f for force, so anything that would need to be forced will be forced. So rmrf is a common thing I use. Be careful with this. You can delete a lot of stuff. Be careful with a lot of these commands that we're using today. So rmrf on dir 1, which is not empty, it wipes the whole directory out. So let's check it. Dir 1 wiped out, no such file and directory. So we wiped that out. So the same thing, let's say, do we have anything in dir 2? All right, so let's recreate this. Dir 1, and let's touch a few things. Touch dir 1, test 1, test 2. Okay, so let's say if you want to delete all the files inside dir 1 but not delete dir 1 itself, you can say rm-rf dir 1 / and use a wildcard, and that will wipe out all the files inside dir 1. Be careful, don't put a space in there, because that would treat it like two parameters. It would delete dir, and then it would delete everything in the current directory. Not what you want, probably. So, yeah, be careful with that. And if you, since it's a -r, you could be, deleting any subdirectories or files or anything inside dir 1, but dir 1 itself will remain. So, let's see, what else do we have to cover for the rm command? So we removed directories, removed everything in a directory. Okay, you can also type, I'm not going to actually do this, rm-rf asterisk. That will wipe out everything in the current directory. I'm in my home directory. I don't want to do that, but that's how you do that. So you can say, actually I'm going to create an example for you. But before I do that, all right, let's just go into dir 1 and let's create a bunch of files. So all right, so there we go. There's a bunch of files created inside this directory, and so we're going to show you how you can delete all of them. So first, I'm going to show you how you delete a single file. The normal simple use case of the rm command, you could say rm, and you can specify a file name. So you could specify test1.txt, remove that file, and now it's gone. Test1.txt is gone. Now, if you wanted to, you could remove all text files. You could say rm, and you could say all.txt, and now all text files are removed. So now we just have these files with no extensions and the JPEG and the directory. Now, I'm going to actually show you the rm-rf, rm-rf asterisk. So this should wipe everything out. And there we go, it's all wiped out. So be careful where you run that. Don't run it in your home directory or anywhere important, right? So there I am. Now, next thing I want to show you, well, first I should create a few example files like test1.txt and jump back here and do the same thing in here. Now I'm in my home directory. Now I'm going to show you how to find things. Finding things is easy in Linux. Now, so we're going to use the find command. So let's clear the screen real quick. And to find something, the default, basically most simple example of this command would be to say find, and then you specify the location. So you say dot for your current directory that you're in. And this will basically find all the files in here, not filtering for anything. So usually not what you want unless you're just trying to come up with a list of all the files in your current directory. So let's clear that out. You could also say find inside Etsy. So you could find all the files inside the Etsy directory. Var log, you could do it in var log, so on and so forth. So there's finding. So you can also, so that's great for listing files. So you can specify the location you want to find them in. But we're going to stick with our current directory for the time being to keep it simple. You can just say name, the name of the file, and say test1.txt. So this is going to match the exact name of the file. So it'll find all files with this name. And we have 4 files with this name. The one right in this directory, one in each of these other directories. So those are all the files that match that name. Now, if you wanted to make this case insensitive, you could say iname instead of name. Doesn't matter because they're all lowercase anyways. So another thing you can do is you could just search for all text files. So you can go like that, asterisk, or a wildcard, and this will find anything that's a text file. So you have stuff like this, all these files, all text files. So you can find them like that. So let's see what else we want to do. So you can also, I'm just going to show you another example of specifying the Etsy directory. All right, so find everything in the Etsy directory. That's a text file, right? Or a .txt file. And there we go. So some we don't have permission to view, and there are actually a lot of txt files in the Etsy directory. So that's everything we're going to show you for the find command. There's more stuff to know, but we don't want to make things too complicated for this guide today. All right, so next command I want to show you is the uptime command. So uptime, it will show you the time that your current system has been up. So this system's been up for 14 days. Load average, the other important thing that uptime shows you, probably more than the number of days it's been up, is the load average. So yeah, load average right here, this is 1 minute, 5 minutes, and 15 minutes. So it's the load average for those spans of time. So anything, if you're on a single CPU system, load average below 1 is acceptable. Anything over 1, it means your system is getting used a bit more than it can handle. It means there are queued up tasks for your CPU. Now, if you have a multi-CPU system, you have to take that into consideration too. But generally, once that number starts getting high, something's going wrong. So if you only have like a 4-core system or an 8-core system and you see a value of like 17 or 19 for this, then you know your system is getting hit really hard and the load is pretty high. So that is a terrific command to be aware of. Now, another command I'm going to show you is the uname command. So the uname command will show system info like the architecture, kernel, OS, etc. So uname-a, A for all, it will show you all the fields. There you go. It shows you everything. Like you're on Linux, it shows you the host name, the kernel version and build, stuff like that. It's GNU Linux, stuff like that. So anyways, that's all fine and great. Not going to get too far into detail with that. There are other switches if you only want to see like the kernel build and stuff like that. That is useful in certain circumstances, but we're not covering that in this guide. So next thing I want to show you is redirection. So redirecting output is important to be able to do. So one thing we can do is you can say ls, and if you want to redirect all this output to a file, you can say test1.txt. So this right here will redirect to this file, and it will overwrite anything that was already in that file, basically wiping the file out. But all that output from ls now goes into test1.txt. So yeah, basically running this will put all that ls output in there. So let's take a look at test1.txt. Now in here, you see that whole listing of files that we basically put those into that file. Now another thing that you can do is instead of overwriting the file, so this will overwrite the file. If you put 2 of these greater than signs, it will append to the file instead of overwriting it. So you do that, it appends to the file. Now, if you want to write text to a file, another way you can do this is you can echo. So we haven't gotten to the echo command, but I'm going to show you this right now anyways. So echo The echo command will just show you, you can echo whatever string you want to echo, and it just prints it out. So you could do this to overwrite test1.txt. Now, if you look what's in test1.txt now, you can see it just, that's that text that we overwrote the file with. Now, you can overwrite it as many times as you want. It's just overwriting the same thing. But as soon as you change that to append, each time you append it, now let's look at the file. See, we've appended a few times here. Now, one thing it won't give you is errors. So let's say if you have an error like this, so ls, now a file that doesn't exist. It's going to say error, no such file or directory. What if we try overwriting that output to test1.txt? I bet that message is going to go into that file, right? It's not. So you run that, it still outputs that info onto the terminal like this. And if you look at test1.txt, it's been overwritten with all the normal output from the ls command, but this output right here is not normal output. This is error output. So normal output is called stdout, and error output is stderror. So that's kind of a problem there. If you want to write stderror to a text file, you can do that. So you can do that by specifying a 2 right here. So you could overwrite like that, or same thing, you could append like this. Let's go with overwrite for now. So we're running a command where we expect this command to produce an error. So it's going to be stderror, and we're going to say number 2. So number 1 stands for stdout, which is the default that we're redirecting. Number 2 stands for stderror. So we're going to use number 2, and we're going to overwrite test1.txt with basically our error message. So any error output is going to overwrite test1.txt. So we can see test1.txt now has the error message. Now, what if we were to run this command like this? We could say test1.txt, and now when we run this, this will just run it by itself. This will give you, it will list the existing file, and then it will give you an error message for the file that doesn't exist. So what if we take that and say 2 and overwrite test1.txt? So now all of a sudden test1.txt, so it still lists, it only writes the error output to test1.txt and not the normal output. So that's also not what we want, right? So if you look inside test1.txt, you can see the error message is there, but the file that does exist and is not an error, that output didn't get written there. Now, you can fix this by taking this same command, and instead you can overwrite like this, and you can also take 2, just add this thing at the end here, 2, take your stderror or your error output and send it to, so ampersand 1 it represents, so just add this little thing at the very end here. This is going to take error output and redirect error output to the address of your standard output. So just adding this one little magical set of characters at the end, and remember, you have to put this at the end. You can't put it in the middle or at the beginning. You have to do it in this order. So basically, your command that's generating the output and the redirection to the file you want to output to, and then this thing that changes error output to also go to stdout. So both of them are going to write to that file, right? Run this, and now no output on the command line. So cat test1.txt. And that has both the error message and the actual file that we wanted to list. So yeah, if all of that stuff seems overly complicated, and you don't want to think about it too much, just remember the basic things. Oh yeah, and also commonly you would use this with append, like if you're appending a log file or something. You want errors and normal output to go to it. But in any case, yeah, if all of that's too complicated, just remember output from any command, you can write it over a file. So file, you can output over a file or append over a file. Those are the super important beginner stuff. All the rest of that stuff, like redirecting stderror to stdout, don't worry too much if that stuff's confusing. For now, just try to keep on moving and move along, and let's cover the rest of this stuff. So let's say if you want to run a program in the background. All right, so here I have a program that you can launch like this, and it basically launches and it does nothing. So this basically, you could call it a server, but it is basically sitting here running. Now while it's running, we can't type any other commands or do anything. So that's kind of a problem. So let's Control C to get out of here. And now let's say if we want to run this in the background, you can just put an ampersand here like this. So ampersand and run it in the background. So now it's still running, but it's in the background. So you can see here, it is this command right here. So basically bash, since it's a script, it's running as a bash shell script. This is that command right here running, and it's basically just running the sleep command. So you can see it's running in the background, currently running right now, but while it's running, we're free to run commands or do whatever stuff we need to do. So that's all fine and great. Now this is not a correct way to create an actual service or daemonize something to use it as a real server. A real server you want to launch the system, and that script running in the background is going to die as soon as I exit out of this terminal. So that's not a real way to set up a service. Just be aware of that, but that is the way you can run something in the background so that you can still type commands and do things in your terminal right here. All right, so the next thing I'm going to show you is how piping works, how to pipe two commands together. And then we're going to show you a few commands that you can use sometimes to operate on files and sometimes to operate on piped input. So let's start here with ps-ef. We'll show you more about the ps command later. For now, just know that that lists the running processes on the system. So we're going to pipe this. We're going to use a pipe like that. So you have ps-ef and then pipe, and we're going to run grep, and more on the grep command later also. So don't worry about it for now. That just matches or searches for strings. So grep-i nginx. So we're going to search for a string nginx in that output, right? So that's the nginx web server in this example. So we're taking the output of this command and we're going to pipe the output of that command into the input of this command. So instead of telling grep to operate on a file, it's going to operate on the input that's being piped into it. So run this, and this will show only the lines that match this value. So that's how you can use a pipe in a command. So we'll show you more on both ps and the grep command later. So next, let's take a look at the sort command. So first, let's take a look at test1.txt. So right now we have a bunch of data. We have some duplicates in here and a bunch of random data, not in any particular order. So you can pipe the output of this command to the input of sort and sort all of the results. So now they're all sorted. Now, another thing you could do is you could, instead of piping the output there, you could really just say sort and run the sort command directly on that file and get the same results. Now, another thing you could do is -u for unique and get only unique values. So now all the duplicates are removed. Now, another thing you could do, a little bit more elaborate, but we're going to show you the unique command. So if you had catted this output and sorted it, you could pipe it into the unique command. You should just be aware of this. So unique, it's going to give you only unique items, and that achieves the same result as just running -u. So you can just run sort -u, and you need the unique command, but the unique command is there, and you might see someone else use it. And yeah, so basically when unique will only give you unique lines, but they have to be sorted first. In any case, another way you can use sort, quick example, ps-ef, and sort the output from another piped command. So sorted, there you go, you see like lines together. So in any case, clear that out. And next command we're going to learn about is the grep command. This one is pretty important. So you can run grep directly on a file like this. You can say grep and then the string that you want to search for, like let's say ABC. We want to search for the string ABC inside test1.txt, and there we go. We see the string ABC occurs on 3 different lines inside this file. One of the lines, it's only part of the line. So you have ABC, ABC, and then ABCD, but it's on that line, so it matches. Now, we can also make this case insensitive, which doesn't matter in this case because it's all lowercase anyways. A -i will make it case insensitive. The other thing you can do is a -v to instead of searching and matching for ABC, we're excluding lines with ABC, and we're showing you anything that does not match that line. So now we see all the output from the file, but no lines that match ABC. So all those lines were excluded. And that's the basics of the two more things I'm going to show you for the grep command. So you can also say grep -r ABC. So Now you're going to specify the string that you're searching for, but don't specify a file, and you specify a -r for recursive. It will search for every single file in the current directory and any subdirectory. It will search for any file, any lines in any file that match this string. So we'll take a look, and a lot of files have the value ABC. Yeah, lots of files here with ABC in them. So let's clear that out. And one more thing we're going to show you, ps-ef. A very common use case for this is grepping output of the ps command. We'll show you the ps command coming up in a little bit. But yeah, ps command just shows all running processes. So you can grep for example, Nginx. So that's a web server. And we see there's a bunch of Nginx processes running. So another use case for pipes and the grep command. So this is going to be a very common command that you use over and over. So very important to understand how that works. So next thing I want to show you is the WC command. WC stands for word count. So let's clear that out of here. You say WC-L, it will show you the line count, or the number of lines in a file. Test1.txt, so you see 21 lines. Now that's actually a more common use case than -W for words. Yeah, so normally you'd see more words than lines, but in this case, yeah, that's how it is with that file. Let's try one more. Well, let's try another example of using the WC command. So WC, normally you use it to count the number of lines in a file or the number of lines of output. So this could be useful. For example, if you were to pipe the output of ps-ef and grep-I for Nginx, so we're basically going to show all processes running that match the word Nginx, so all of our Nginx processes, and you can further pipe this to WC-L. So check the number of lines. We're going to get the line count, and we see there are 10 lines. So that means there are 10 processes that match the word Nginx. So maybe if there's a certain number of processes you expect to be running, and you don't want to look at each one of them, you just know there's supposed to be 10 running, you could run this and say, oh, there's 10 running, I've got that. So that's a useful use case, and this shows how you can pipe the output from one command to another command, and then yet to another command. So that's a 3-command pipe, or a chain of 3 commands, and all piped together. So any case, moving along here, another command I wanted to show you is the sed command. So you can say, now, sed is the stream editor, sed for stream editor, and normally it does a lot of things, but the main thing people normally use this for is just to search and replace text in a file. So if you know one string you want to replace, you can just replace it pretty easily. So, for example, you can say our file test1.txt has ABC in it a few times, so you can say sed -s. You're going to run a little sed program here in single quotes. Now S stands for swap, I believe for swap, but basically it's what you use to replace. And you can say ABC, this is the string you want to search for. And then you can say XYZ, this is what you want to replace it with. Say slash and dot and close that single quote, and then specify the file test1.txt that you want to operate on. Now this will read the file in and replace anything that's ABC with XYZ in the output. So it reads the file, swaps those strings, and then prints the output. Now, if you want to actually change the file, right now the file is not changed. If you want to change the file itself, you can say -I to edit the file in place. Now notice no output from that, but the file was changed. So if you cat test1.txt, you'll notice anything ABC was swapped to XYZ. So that is sed. Now, next thing I should show you is awk. Normally, sed and awk, two very important string editing or text parsing tools that you'll use. So awk is generally used to split text apart into columns. So let's try a first example. We will run something like this: awk command, and then a tiny little awk script. Now, awk is actually a complete scripting language. I did a separate video on that, and there's a lot to know about it, but most cases you just use awk to, most day-to-day cases you just use it to split text into columns. So here we're going to print columns 3, 5, and 7 of the file test1.txt, and it is by default split by white space. So we don't have any different columns in that file. So let's create another file as an example. All right, so say if we have a file like this, test2.txt, we have a bunch of columns of text separated by spaces. Now this is just an example, not something useful, but you can run awk on this. So run awk on test2 and take columns 3, 5, and 7. So the previous file we only had one column, so that wasn't very useful. So we can run this, and this will give us columns 3, 5, and 7. Not super useful, but that shows how that works. Now, you can also split this up. So this, when you run print on this and separate the columns by commas, it will automatically separate them with spaces in the output. But what you can do is you can put your own strings in here. So create a double quote and say something like this. And then over here, put another string, maybe separate it by space like that, and then put another one like this. And you see now here we're separating by a space, and then this one we are separating it with 2 dashes like this. And at the beginning it just says fields. So fields, so any string we want to print out, this will print it, and then it will basically prints this string, prints a column, this string, column, this string. So you can format your text in interesting ways like that. Now, next thing we're going to show you is how to change the field separator. Now, this is not going to be useful for this file, but you could change the field separator with a -f colon. Now, that's only going to give you, so there's one colon inside the file. Actually, yeah, that's not useful at all. That prints nothing. So you could use, you can change this field separator to any character or any string you want. You could separate by colons, or you could separate by 2 characters like this, TC, or AB. So anytime it finds AB on a line, it will split right at that point. So you can, it's very flexible. You can split on anything you like. But for now, let's start with a colon. So we want to split by colon, but instead of this file, let's try Etsy password. So we're going to split columns from the Etsy password file. So columns 3, 5, and 7. So we can split those out. We have some ID and a few other things. The shells, so it takes some of the lines from that file. So not super useful, but say if you wanted to split out just the first column from the Etsy password file, just like this. So you can split out the users from that. So yeah, that's just another example. So splitting with the colon as a field separator, another common one for CSV files, you might split them apart with a comma. Any case. So that's pretty much all the important stuff you'll need to know for the awk command. Now, actually, one more thing. I'm going to show you how you can pipe output from PS. So you can print the first column of your output from the PS command. So you can basically split out the user from it. So normally PSEF would look like this. Say if you just want to grab this first column, you can grab that column like that. And you might also decide to print out the second column if you want. You can do it like that. So there's that. And then one other thing I wanted to show you. Let's move back to before I forget, let's do sed. One more thing with the sed command. You can you can use this with pipes as well. So I feel like I should show you an example of this. So you could say, for example, root, and replace that with X's like this. And let's give this a try. There we go. Anywhere you see the user root or the word root anywhere in this text, it replaces it with X's like that. So that's just another example of using it. Not a useful one in this case, but you can pipe the output from one command into sed and replace some of the output. All right, so next command is the cut command. It's similar to awk. It's more simple than awk, less functional than awk, and only supports a single literal character as a delimiter, but it is very common, so you should be familiar with it. So cut -D, and you can specify the delimiter as a space, because by default it's a tab, which is a little bit different from awk. Now, in any case, -F will allow you to select fields. We're going to select fields 1, 2, and 3 from test2, right? So there we go, fields 1, 2, and 3. You could also, let's say if you removed field 1, boom, it looks like that. So that's how you'd select different fields using cut. I personally prefer awk, but you could use whichever you like. Now, another command you can use is cut. You won't have to specify the delimiter if instead of fields, so -F stands for fields, instead you could do -C for characters. That will take character 2 and character 3. So there you go, characters 2 and 3. Now you do like characters 1, 2, and 3 like this. Whoops. 1, 2, and 3 like this. Anyways, that's that. Basically, you're basically cutting out characters 1, 2, and 3. So it's a little bit easier if you just want to cut characters. So a -C for characters, a -F for fields, and if you're doing -F for fields, you're usually going to want to do a -D to specify a field separator. Anyways, that's all I'm going to show you for the cut command. So next I'm going to show you a few commands that you could use to output text. So let's clear this out of the way. And the first one I'm going to show you is the echo command. So we've seen this a little bit already. So you can type echo, and whatever text you want to type, just type the word test, it outputs that. And you could do something like this, it outputs that, right? So you could also put it in quotes if you want. So also you can echo out variables, for example, the path variable. So start a variable with a $, and then the name of the variable, in this case our path variable, that will show you the current path. More on that later, more on the path later anyways. Now you can echo, so you can echo some text to a file. So if you run echo, you can say output.txt. Now this will redirect your output over this text file. So now if you check the text file, output.txt, you have that text that you echoed. Now you can, I already showed you about redirecting, but you could, overwrite it as many times as you want, and same thing, right? So you could also append instead. Append as many times as you want, and now you see we've appended each of those, right? So another thing you could do, so if you have a large file, for example, maybe a really large log file or something along those lines, and you don't want to delete it, maybe you just want to overwrite the file to truncate it down to 0, you can do that with this also. You can say echo, redirect, so you're echoing nothing over a file, say a large log file. In this case, let's just do output, even though that's a very small file. That will wipe the file out. So output will now be empty. Now, if you had a really large log file, like 100 gigs or something, and it's eating up your disk space, but you can't delete it because it's being written to by a process, you can just truncate the file to recover your disk space without actually deleting the file. So yeah, just a useful example there. Next command is the cat command. So you can say cat test1.txt, and that will print out that file. Now, you can also cat 2 files at once. So cat stands for concatenate, and the reason it's called concatenate is because you can cat 2 files, and it will concatenate both of these files and output them all, and concatenate them together and output the whole thing. So you can see the output of both of those files right there. So next thing you can do with cat, you could use cat to overwrite a file. You could redirect the output from cat to output.txt, and there we go. We've overwritten it. So that's the cat command. A few things you can do with the cat command. So we've covered echo and cat. Now we're going to cover head. So if you want to see the first 10 lines of a file, you can say head test1.txt. It's going to give you the first 10 lines of a file. Now, you can also do this with output. You can page through piped output 2, ps-ef, head. First 10 lines of the output. Now, same deal with tail, except tail will give you the last 10 lines. So tail, last 10 lines. And same deal with piped output, tail, get the last 10 lines of piped output. Now, another very important thing to know about tail is you can also follow things. So not only will it show you the last 10 lines of a file, but you can tell it to follow the file, meaning any new updates that are written to the file will also be, you will see those as they're updated. So for example, let's try tailing a live log file right now. So paste this, tail-f, and we're going to tail our Nginx access log. So we see a bunch of things have been written to this file. So let's see what happens when this updates. So see right here, see the log is changing? So there you go. So as new things happen and as new events are written to this log file, we see those new things that are getting appended to the log file update at the bottom of the file as they happen. So just Control C, get out of there. So that's how you follow a file with tail. Very useful for watching log files. Now the next command we're going to learn is the more command. So more allows you to page through output. So you can use something like this, more varlog dpackage.log. So more will allow you to page through this. You get space like this and page through it. Shows you the percentage. You can go back up. You can use the arrows actually to go down and up. And Q to quit. Now you can also do that with piped output like this. So that's another example of that. Now, more is the old traditional tool, and there's a new tool that has replaced it. And I say new, but it's actually been around almost forever, called less. So instead of saying more, you can say less, and less is a better tool. More is just kept there because it's standard, but less is a better tool. So less is more. So we can run less. Now with less, you can Q to quit if you want to quit. You can use space to page down. You can use enter to go down line at a time. You can use arrow keys to go up, down, right, left. You can use G to go to the first line. You can go Shift G to go to the end, G to go back to the beginning, 5G to go to line 5. And you can also search for things. You put a slash like this and say, let's search for config. That's going to highlight anything that's config, and lowercase n to find the next match, and shift n to find the previous match. And that's how you search in the less command, and Q to get out of it. Now, one of the advantages of using less instead of something like Vim or VI is that it does not need to load the whole thing into memory, so you can open very, very large files without performance issues. So it's better for opening like gigantic log files instead of using Vim. So in any case, next thing I want to show you is the diff command. So you can see the differences between two files. Diff file1, test1.txt, test2.txt. And there you go. It'll show you the differences. These are very different files with almost nothing the same. So the stuff on the left side here is in one file, and the stuff on the right side here is another. Now, if these were more similar, you'd see more things. This would be more interesting output to look at, anyways. So that's the diff command. Good to be aware of. That's as far as we're going with that one. So next thing I'm going to show you is the nano command. So nano is a simple terminal-based text editor. It's super easy to use. You can navigate with the arrow keys in an intuitive way, and the commands are listed at the bottom of the screen. So you can type nano by itself, and there you go. You have a text editor. Control X to exit. Now, let's try it with test1.txt. So you can open a file like this. And there you go. You got the file, the arrow keys to move around. You can just type as you feel like it. Now, the thing with Nano is it may not be installed on every single system. It's very common these days, so chances are you have it and you can get it installed pretty easily, but it might not be everywhere. Now, Control X to get out of here. You can choose whether or not you want to save it. Let's just save it, hit enter, there you go. So it's super easy to use. All the commands are on the bottom, but it may not be installed everywhere. Now there's another text editor called Vim or VI. Now the Vim is newer than VI. It's the improved version of VI, of the old VI text editor that's common on Linux and Unix systems. So VI or Vim is not intuitive. It's hard or frustrating for beginners who don't know what they're doing, but it's standard. You should expect to be able to find this on basically any Linux or Unix system within the last, I'm not even sure, probably the last 50 years or so. But I think I would have to check on that. But it's been around basically forever. Now, you can count on this editor to be present on almost any system. So it's standard, and that's why it's important to know it. And just for that reason, but once you do get good with it, it's really powerful once you know how it works and you know all the shortcuts. A lot of people use it as an IDE replacement, as crazy as that sounds. Now, it's very old systems have VI installed. Newer versions have Vim installed. So when I say VI, I mean Vim. So Vim, now you might have the Vim command, or you might have the VI command, or both. Now, the VI command is just a VI is it's probably a link to a link to a link, but VI is just an alias for Vim, basically. The modern text editor that you're going to find on most Linux systems is just Vim. I type VI out of habit, so you could say VI test1.txt. Now, there are a lot of really terrific shortcuts for this text editor. I'm just going to show you the ones you need to get around and edit text. Just to get by, just survival skills. There are a lot of really useful things you can do with this, though. So, first thing, how to exit VI. Well, if you haven't changed anything, you can type :Q. So this frustrates people. They don't even know, they start VI and they don't even know how to get out of it. So :Q to quit, and you can just quit right out of it. So if you have any changes that you want to save, you could just say W to write any changes and stay inside the file, or if you want to save and quit, WQ to save and quit. Now, let's say if you do have any changes and you don't want to save them, but you just want to quit, quit will say, hey, you didn't save anything, so you can say Q ! To force quit it. And there you go, we've quit without saving. So what else? Okay, so one more important thing to show you, when you're in Vim, you can use your arrow keys to navigate, and you can use commands to do things. Now, you can't just start typing things and have it work. So if you type something, it's going to be a Vim command. Now, if you type the command I, that puts you in insert mode, notice it says insert down here at the bottom. So you can still move your cursor around depending on which version of Vim that you have installed. But when you're in insert mode, you can actually type text and insert things. So you can type stuff like that, right? So if you want to get out of this insert mode back into command mode, hit escape, and now you're back in command mode, and now you can't just arbitrarily type text and do things. But basically everything you do is like a shortcut to something. So there are a lot of nice shortcuts, like you can YY to yank a line, P to paste that line, DD to delete the line. There are a ton of other really useful shortcuts for it, but that is, so when you're in insert mode, hit escape to get out of it. So just be aware there's insert mode and non-insert mode, command mode and insert mode, and there's those few things like right quit to get out of there. And that's basically everything you need to get by in Vim. Now, next thing we're going to cover is users. So for people who are super new to Linux and Unix, the root user, or root, is basically the default Linux admin user. It's basically the admin user for the system by default. Now, you can, first command I'm going to show you is who am I? That will show you who you're logged in as. I named my user user1. Wasn't being too creative there. You can also say who. Now, who will show you who is logged in right now? I'm the only person logged into the system right now, but it would list who is logged into the current system in case someone else is working on it. Now you can say last. This will show you a list of last logged in users. So this shows you everyone. It shows you every time the system rebooted and the users who have logged in, which is basically just me, user 1. So yeah, there we go. Now you can also say ID user 1. So the ID command will get info about this user. So this shows you my UID, GID, the groups I'm in, and a bunch of other stuff, or basically just that stuff. So if you want to change the password for the current user, you can type PASSWD. Now I don't want to do this. It wants your current password, and then it's going to ask you to change it, but I don't want to do that. But basically just PASSWD will let you change the password, and it's going to prompt you for everything you need. If you want to change someone else's password, you can say change the password for user 2. You need to be root to do this, so as my current user, I won't be able to do that, and we're not going to do that now. So anyways, moving along. Now, if you were root, you would be able to change passwords for any user you want if you feel like it. So next thing I'm going to show you, super important in terms of users and authentication and stuff, is the SU command. Now, SU for switch users. So SU dash, now technically you run SU by itself and the username, but usually you want to use their profile, so you specify a dash, and that will initialize the profile for the user you're logging in as. You type this and then type the password for that user. Now I'm logged in as that user, and this is what a normal prompt by default in Ubuntu and most distros. You'll see the user you're logged in as, an @ sign, the host name, the current directory you're in, tilde for your home directory, stuff like that. I got rid of all of that for my user. So anyways, it might look a little bit different for you. So anyways, that's how you can log in as another user. You're going to have to type their password to do it. Now you can also become root like this. You can say SU to root. You'll need root's password. So you can say I'm not sure if I have a root password. Any case, yeah, I may not have said it because this is not normally how I become root on the system. So we're going to get to that in just a bit. Next thing I'm going to show you is the sudo command. Now sudo you can use to run things with root permission, or technically, depending on how you configure it, permission for any other user on the system. So configuring sudo is beyond, it may not be installed by default on all systems, like say Arch or Debian. You may not even have sudo installed, so you're going to rely on using SU to become root, to get root permissions. But on Ubuntu and a lot of other systems, you're going to have sudo installed by default, at least for one admin user. So on this system, I do have that installed, so you can go sudo, and for example, you want to do something that requires root permissions, you can say apt install nginx, so you can install a package. I've already got this installed, but this command requires root permission to install that package. So you use sudo before the command to run it with root permissions. And if you are in the sudoers file and you have permission to run things as root, you will just have to type your password in and you can run that as root. So another thing you can use that for, sudo, you can run sudo and su. So you're using your sudo permissions to run the su command to become root. So if you're in the sudoers file and have permission for this, you only need your own password to become root. And there we go. Now I'm root. So who am I? Root. And exit on out of there. Now typically a $sign means you're non-root, and a £sign means you are root. So £sign for root, $sign for normal user. And even when I switched to user 2, you saw a longer prompt, but there was still a $sign at the end. Now, let's see here. Adding users. If you want to add a user, there's 2 tools to do this. Now there's a nice script. There's the add user command. This is much more user-friendly, and it prompts you for everything you would possibly need and creates the password for you and everything. If you're on a system that has this, it's recommended to do it. So you can say like user3. This would add a user called user. Okay, so you need root permissions for this. Let's use sudo. Okay, user3 already exists. Okay, user4. Now, see, it creates a group for that user, creates a home directory, copies files from Skell. Now it's going to ask for a password. And that's fine. It tells me it's a bad password. You can enter in some details for it. No big deal. And there we go. We have now created user4. And that's all there is to it. Now, some systems may not have add user. Add user is just a convenience script that's more user friendly, and ultimately it calls the user add command. So add user, convenient tool, but user add is actually a built-in system tool that is it's an actual binary. It's not a script, and it's a built-in system tool. So it's more standard. User. Okay, let's create, what did we create? User4, so let's create user5. User add -m, so we're telling it -m for home directory creation because this does not create a home directory by default. So run that, and we have created this user with a home directory. Now, it did not, notice it didn't prompt us for a password or anything. So you want to set a password for this user. User5. Oops, and need root for this as well. It's going to complain that it's a bad password. That's fine. I'm going to remove these users later, and there we go. Now we have added a user5 and set a password for it. So that's everything in terms of users. Now let's talk about permissions. So if you run a command like this, notice you see the long listing for all the files, file names here, and all the other stuff, the user here, and the group, which basically usually has the same name as the user, but in more elaborate setups it's going to be different. Anyways, notice permissions over here. So the first character here is it will be a D for directory, L for, it's a dash if it's a regular file, L for a link, and so on. It tells you what type of file it is. But then notice you have these RWX, this combination of RWX. So this first set right here, read, write, execute. That's read, write, execute permission for the owner of the file or the user. Those are user permissions or the owner permissions. Now, this second three right here, read, write, execute for the group. Now, in this case, we only have read and execute permission for the group that owns this folder right here, this directory. So this right here is read and execute permission. So read, write, execute. If you had write, you'd see a W here instead of a dash. A dash means you don't have it. So read and execute permission for everyone or other. So read, execute for other. So basically the first three, user, then group, and then other. And the permissions you can have are read, write, or execute. Now, important thing to know, so obviously read gives you read permission, write gives you write permission, execute gives, you need execute permission if you want to execute like a script, for example. So notice this has no execute permission. Actually, you should have that. You can, I'll show you later, there's a way to run a script without execute permission. Like this one, for example, no execute permission, and it shouldn't have it for anything, but notice that the directories have execute permission. Now, for a directory to work properly, it needs both execute and read permission to be able to even read it and list the things inside a directory. But yeah, so write permission to actually create files inside a directory. So anyways, that's how permissions work. So that's the basics of how permissions work. Now, we're going to show you the chmod or chmod command that is used to change the permissions on files. So let's see here, test1.txt. Now you could say chmod all plus read, write, execute test1.txt. So that's going to grant everybody permission everybody all permissions to this file. So read, write, execute for everybody. So you have who you're assigning the permissions to. You have basically, so you have the chmod command and the file itself and the permissions. So for permissions, you say who you're assigning permissions to. You're going to do a plus and the permissions you're adding. Now, so who you're going to assign them to, it could be A for all, U for user, G for group, O for other, which is basically everybody. And then you can say the permissions you assign will be read, write, or execute. And now this plus sign here, plus would be add those permissions, so whatever's there already. Minus would be remove those permissions for whoever you specified. And an equals would be to just directly set the permissions to be that. So for example, you could say for other minus write and execute like this. So run this and check the file. Now we have for other, we've removed write and execute. And now you could also say user equals read write. So that sets the user permissions to only read write. You'd say, you'd also remove permissions. Commonly you might just say OG read write execute. And maybe grant everything to user. You would grant maybe everything if you feel like it. So there you go. That's how you can change the permissions for this file using so that basically covers everything about how you would change permissions for a file. Almost everything with the chmod command. That's all the important stuff to get you by and change things. One really handy thing to be able to do is if you want to change permissions not just for one file but for a directory and the contents of that directory, you can use a -R, and that will be recursive. So chmod -R, the permissions you want to assign, and the directory you want to do it for. That is very handy if you're chmodding whole file systems or whole directories even. Now, another thing to be aware of is that you can also use numerical values for to specify your permissions, but that's a whole nother can of worms, and we're not going to cover that, but be aware that that is there today. If you want to go deeper, that's something else to look into. So you could say like chmod 700, we might say 744. So there you go, 744, 7 is everything, 4 is read permission and read permission. So yeah, that's the first, that's the user, group, and those are the bits for user, group, and other. So anyways, that's as far as we're going to cover those for today. I actually have them all listed in all the details on that listed in the document that is linked to in the description of this video. If you want to dig deeper and learn more about that, just check the link in the description of the video. Now, that was a chmod command. Now next you're going to want to learn about the chown command. So if you want to chown a file, you could say, whoops. So you can say chown user1 test1.txt. Now if this is already owned by this user, but you could chown it like that. And that would change the ownership to that. Now, just to show you, you can use sudo chown user2. Now, if you want to change it to, generally you're going to need root permissions for this, but to change it to anything meaningful other than what it is, but you can change it to user2 like that. And notice this file is now owned by user2, but the group is user1's group. Now, you can chown, if you want to chown the group too, you could say user2. So the user colon group, you say chown user colon group, and then the file name, and that will change both the user and the group in one shot. And there you go. It's owned by user 2, user 2. Now, again, for this, similar to the chmod command, you can use -R to change or fix the ownership of files across an entire directory recursively. And that basically covers everything you would want to know about the that's everything you would want to know about the chown command. So let's move along here. The next thing I want to show you is the df command. So you can say df, and this is going to tell you disk usage for all file systems. So df shows you the usage. Now, it's easier to read if you add a -h. So this is what you're going to do most of the time. -h, you can see gigs and megs, pretty print like that, kilobytes like this. So next thing you should be aware of is that if you only want to see it for a certain file system, you can say df-h dot. Now dot will specify it. Basically, that's specifying a directory, and you're going to specify the current directory that you're in. So it will show you the disk usage for the file system of the current directory you're in, which is the root file system, which is right here. I have a simple system where the only real file system here is this. Now I have others, but I just haven't mounted them. But let's say if you wanted to do something else, you could say something like var. Let's say var. If this was on a server, this would commonly be a separate directory, so it doesn't fill up your root file system. So you could check. In this case, it's still root, but you could check the usage of var. So let's for us, we should do as an example media user1. Check this device. We can check the usage on that device. So that's everything you should know about the df command. Now let's try du. So du-sh, the most common usage of this, will show the sizes for all files and directories in the current directory in human readable format. So right there it shows you all the sizes. So with this, you can basically see what is using up all your disk space. So videos has a gig of files in there. My wallet.dat only has 84K. So there you go. Now to make this more convenient, you can pipe this to sort. Here's where sort becomes pretty useful. And you can say sort-h. So sort human readable. So since these are all human readable values, they're not actual. So like 1 gig is bigger than 68K. So sorting alphabetically won't help you with this. So you need to sort by a human readable output, something that intelligently knows the difference between 68K and 1 gig, right? So anyways, -h will achieve that. So you can sort them in order, giving you the largest files at the bottom right here, and going up they get smaller and smaller. So any case, you can also use the free command. This will show you memory usage on the system. Now, normally you should just use, similar to the other commands, free-h. Now, I'm going to go ahead and take this. So you can see the output a little bit better. All right, so there we go. Now, you can see it gives you total memory usage, used, free, shared, buffer cache, and available. So here we have like 32 gigs, well 31 gigs, but in any case, you have the total amount of memory, and we're only using 7 gigs, but we only have 5 gigs free. So what's going on there is that a big chunk of my memory is a little bit is used for shared, but a big chunk of it is used for buffers and caches. So this memory is just being used to cache things to disk so we can access them more quickly, but it's still available. So if you take free memory and what's being buffered, you have the actual available memory for new applications that would be launched. Now, so this is basically the real free memory that's free for application usage, 22 gigs. So Swap space is 2 gigs, and we have used 0 of it, and we have 2 gigs free. So that's how that works. All right, so next, so that was du and free. Next, we are going to learn about the ps command. So ps by itself shows processes running, but these are all procs with the same ID and TTYs. So basically anything in my current terminal or TTY and that have the same user ID. So not a whole lot, only bash and the ps command itself will show up there. So if you want to see everything, you can say -E for everything and F for full listing. And that will give you a full listing of what's running on the system, all the processes. And let's say if we pipe that to head, you can see you have the UID, the PID, the PPID. So this is the PID or the process ID of each process running. This is the user of that process that the process is running as. Now the PPID is the parent PID, whatever parent of this current process is. And in any case, you also get the time, the TTY, and the actual command for what was run. Now, that PS-EF is very common, and it's what I'm used to. Some people prefer PS-AUX. Now notice this is different from -AUX. It's just AUX with no dashes. This is the BSD format, and so it's similar, but these are BSD options, and they have more useful columns, I would say. So yeah, let's just pipe this to head too. Okay, anyways, user, PID, CPU percentage, memory percentage, VSZ, RSS, resident set size for memory usage and stuff like that. It gives you the command and some other stuff. So yeah, a little bit more useful. In any case, another thing you could do is PS-EF, and you could say dash. This is pretty important to know, getting a little bit elaborate, but sort modulus CPU. So you can sort by CPU. So you can see what is eating up most of your CPU usage. And you can also sort by RSS for memory. All right, so you can actually sort by RSS like this, but that's not going to be too useful unless you actually select the fields you want. You can select fields like this. I know this is a little bit too complicated for what I wanted to do in this video. So if this is too complicated, skip past this one specific thing, or don't worry too much about this, but this is pretty handy to be able to do. You can select the fields. One of them is going to be RSS, and you can sort by -RSS. And you're going to see as you scroll up, RSS it's pretty small for most of these. It's basically 0. But as you scroll up, you're going to see they're getting bigger and bigger, means they're eating up more and more RAM. And at the very top there, you see GNOME Shell, OBS. OBS is what I'm recording this video with now. And you see Google Chrome and MySQL eating up tons of RAM. Also have Jekyll running in the background with Ruby 3 and some other nice things. The next thing I would want to show you is the kill command. So the kill command is generally used to kill a process. This command is actually used to send different signals to the process, but most of the time those signals are just used to terminate the process. They can be used for other things, but this is as far as we're going to go with that in this video. So basically normal usage, you would say kill and put the PID. Like for example, 150, 746, you could kill it. So this is going to send a signal to, this is a kill signal, but it can be caught. So that will send a term signal to the process. It could be caught. So if you want to force kill something, you say kill-9 to send this. This is basically specifying signal number 9, and that is for a signal that can't be caught. So instead of using the default term signal that gets sent, you're going to use the kill signal, which is kill-9, and you would say the process like this, 746 if that's the PID of the, so this is going to be the PID of the process, and you say kill-9, that basically force kills it. So this one, this one will allow the process to catch the signal and maybe do some cleanup, close log files, whatever it has to do before it actually shuts down. So if it's having some problems and it can't do that stuff, it might just stay running and not die. So if you want to force kill something, kill-9 can't be caught, it can't be handled, so it will just forcefully kill the process without, flushing logs or cleaning up or anything like that. So that is, yeah, you'd prefer to run just regular kill first, and then if it doesn't work and you need to kill it, do kill-9. So for example, if we want to kill one of our Nginx processes, you could say kill this process right here. Okay, so it need to be root. And there we go, we've killed it. Now we could try another one, and let's just try a -9 so we can kill that like that. And we're not going to see any of those same processes running now. So it looks like it probably spawned a few new ones. I'm not sure. It doesn't matter. This is not an important server, so no big deal there. Normally, you wouldn't just randomly go killing Nginx processes unless you had like a real reason to do it. So in any case, that's how you use the kill command. Now, next useful thing I want to show you related to processes is the top command. So this is super common and installed on almost all systems. So you type top, and this gives you a live view. Unlike the PS command, this gives you a live view of what's running on the system right now. And notice it updates every now and then. So up here you have this header section that gives you a bunch of info about the system, load average, uptime, number of tasks running, CPU, memory, swap, all that stuff. And then it gives you this header up over here and all the processes running, and it sorts them as their usage changes. So for the top command, you can use Q to quit, or you can do F to manage fields, and here you can shut some fields off or enable some fields. Hit escape to get out of there. So let's say, see how we have PR, NI, and vert. All right, so let's say if you want to get rid of some of those, maybe these two are not super useful. Maybe remove time and this guy right here. There you go. You get a little bit more simple, fewer columns here. And let's see. When you manage fields, you can also, you can use a space button to enable or disable, and it tells you up here at the top what to do. Now S selects sort. So say if you want to sort by CPU, you can say S. Now you're going to be sorting by CPU. If you say S on mem, you will be sorting by memory. So then you can get on out of here, and now these are, notice, sorted by memory. Now you could also F, you could sort them by command as well, which is a little bit silly, but you could do it if you wanted to. And notice they are now sorted by command. So those are the important commands for the top command. Let's Q to get out of here. There's a ton of very obscure and things of questionable usefulness that you can know about the top command. I'm going to make a huge, really long video about it, but a lot to know about it. I'm not covering that in this video. So next thing to learn about is the htop command. Some say it's better than top. I think it's more simple and straightforward. It is newer, and it may or may not be installed on all systems. It's worth installing if you want it. But htop. Now htop gives you this nice visual representation, and you can kind of configure top to do similar things. But in any case, it will show you all the cores on your system and their usefulness. So I have an 8-core system. This is how my cores are being used. Shows you a bunch of stuff like uptime, load average, that kind of stuff, memory, swap. And it shows you a similar thing. Gives you columns, and it shows you all the different processes running on the system. Now this would probably be a little bit better if we were zoomed out a little bit, but I think this is actually okay. We see everything on the screen right now. So a few commands to learn. Obviously Q to quit. So that's pretty obvious. Now you can use the arrow keys to navigate like this. left, up, down, left, right. Now you can tag things with the space bar. So for example, if you find a process, and let's say if you want to kill, you can type space, and let's say if you want to kill a process. So you can space to tag that, and you can type K to kill the process, and this will allow you to send signals. Now remember, 9 is sig kill, that was basically force kills it, and 15 is sig term, that was the default of the kill command. And you can basically select what you want to send, like a regular kill, or force kill, or a regular kill, or whatever signal you want to send to it. Now I don't want to actually do that, so I'm going to hit escape, but if you select one and hit enter, you can kill the process like that. So that's pretty handy. So the other thing you could do is you can press F6 and this lets you sort, this lets you choose what you want to sort by. So for example, maybe you want to sort by percent memory. Hit enter to sort by memory, and you see the little triangle here, it shows that we are sorting by memory. And you can type I to reverse the sort order. Oops, get out of there. Capital I or Shift I to change the sort order, to invert the sort order. Notice smaller memory use at the top. Hit it again, and it swaps to this. So that's everything I want to show you for the htop command. But yeah, live view of processes running on the system. So next thing I want to show you is some commands having to do with disks. So if you want to see the block devices on your system, you can use the lsblk command and view the block devices. I actually have a pretty fair number of block devices. Now this is cluttered up with all these loopback devices for the controversial Snap system on Ubuntu. So those aren't real disks. Yeah, anyways, ignore those. But for example, these are real disks. Like SDA is a disk, and it has partitions 1, 2, and 3. Same to SDB, 3 partitions. This one has 4 partitions. This one is actually mounted right now. And this is NVMe. This is the drive that I'm booted into right now. So my boot EFI partition, and yeah, anyways, root partition. Anyways, so that's the lsblk command. Now you can use df-h to show what is mounted and on what. So for example, root is on partition 3 of this NVMe drive, which is what we saw above here. So you can also mount disks. So you could say, for example, I'm not going to really mount this, but you could say generally you're going to need sudo for that. So sudo mount, or just run it as root. You say dev sd. Let's just try it. All right, let's try SDA3. Yeah, that looks like I forget which OS that is, but let's give it a shot. SDA3, and let's mount it over /mnt. So this is the device name, and this is the directory we want to mount that device on. So run that. So now we have this disk mounted on MNT. So let's see what's under MNT. You can see this is probably my Arch system or my Gentoo system. I'm not sure which. Anyways, if you want to mount it, you can say sudo umount MNT, just specify the directory, and it will unmount it for you. Now, if you want to, if you have SD cards, USB drives, and they are running the exFAT file system, which is pretty standard for like digital cameras or whatever else, the exFAT file system is really popular for a really popular and useful cross-platform file system. So if you want something to work on both like Linux, Windows, or Mac OS, exFAT is the way to go. So a lot of USB drives and SD cards are formatted with exFAT. Now, if you can't read your USB drive or SD card on Linux, there's a good chance the exFAT packages have not been installed. So I'm not going to show you how to install that here. I already have it installed right now, but check the link in the description for some instructions on how to install those. They're in the guide that goes along with this video. So next thing I'm going to show you, I'm not really going to reboot the system that I'm recording this on, but if you want to reboot the system, so you need to do this with root permissions or as root, but you can say sudo reboot to reboot the system. If you want to shut the system down and power off, you could say Alt-P. You can also say power off, or you can say shutdown -H now to tell it to shut down right now. So those will shut down the system. I'm not going to do that right now. Multiple different ways to do it. Typically, I don't use power off or shutdown. I personally use Alt-P just because I've been using it for the last 20 years, or way more than 20 years, more like almost 25 years, and I'm just used to it. So that's what I do, just muscle memory. Also reboot if I just want to reboot. So I use reboot and Alt-P to reboot or power off the system. Now, if you want to exit the current shell you're in, you can type exit, and that will close the current shell you're in. I'm not going to do that now because I don't want to close the terminal that I'm doing these command demos with. Next, I'm going to show you how you would unzip a tar file or untar a tar file. So if you have a tar archive, so I'm going to show you the basics of what you need to do to untar, gunzip, and basically unzip most common archives. But I'm not going to show you how to create them in this video, just trying to keep this short, even though it's already been going for a pretty good amount of time. It's longer than I planned for it to be, but check the link in the description for way more info on compressing and uncompressing and archiving a ton of different formats. I have a ton of different formats that you might come across on a Linux system or any other system for that matter. But anyways, I'm going to start with the tar command. So right here we see two archive files. So we see a tar file and then a gzipped tar file. So tar.gz means that this was first tarred and then gzipped. Now, you might also come across something that's just a .tgz. That's the same thing. It's just a short. It's just short for tar.gz. So, in any case, if you want to unarchive a tar file, you can say tar x vf. V is for verbose, it's optional. F means you're going to operate on a file, and X means extract. So you can say archive one.tar, and that extracts it. It just had this one text file in it, which is what I already had in the directory. So I'm just showing you just for demo purposes. And yeah, so the file is still there, but you can unpack it as many times as you want. Now, if you want to do that with a tar.gz file, you can just add a z to it. The tar command can handle GNU-zipped or gzipped files, so add that there and do that with this gzipped file. And there we go. So I'm actually going to remove this. I want to see what this does. Archive.tar. All right, so we only have this gzipped file, and you use a z to unzip it and then unpack the tar file. So there we go, unpacked a tar file and the test file that was inside it. So it unpacked this into this tar file and then unpacked the text file that was inside that. Now you could also gunzip it like this, gunzip or gunzip, archive.tar.gz. You could gunzip it like this, and the gunzipped file already exists, so overwrite it, and there you go. So there you go. All we have is the tar file now. So that's worth knowing. So yeah, if you want to zip or unzip, if you want to gunzip something, or if you want to gzip something, you could gzip. This is useful for compressing log files that are really big. If you want to save some space, you need to clean something up. But in this case, we're just going to show you how to do it with this file. So test1.txt, gzip it. So you see, it's not a tar file, it's just a text file that has now been gzipped. So the original text file is gone, you just have the gzipped version of that. If you want to gunzip that, you can just say gunzip. There you go, gunzip it. And there we go, it's unzipped. So that's how you zip and gunzip things. Now if we happen to have, I'm going to quick show you bzip2. This is somewhat common. So you have something in bzip2 format or bz2, you would -d and the name of the file to uncompress it. I don't have one right now, so we're going to skip past that. Now, similar thing, if you have an XZ file, XZ is a great compression algorithm. So if you happen to have that, you can use onXZ to uncompress this XZ file. And if you just happen to have a zip file, you can do a similar thing. You'll need the zip software, but unzip some data.zip. So that's how you would unzip a file. Now, if you want to learn how to create these, compress them, and all that stuff, check the link in the description. Now, you may or may not have the zip command, the bzip command, or there's a ton of others. There's like rar and like a whole bunch of other formats. If you want to know how to install the packages for those formats and how to compress and uncompress them, just check the link in the description for all those details. But that's as far as we're going with that for now. So check the link in the description for all of that stuff, and let's move on to servers and services. So if you want to check all the services on your, so basically if you want to list all the systemd, we're assuming you have a systemd based system. If you don't, it's going to be a bit different, but most mainstream Linux distros in modern times run systemd. It's been controversial, but it is what it is. That's how things work. So this is a very useful thing to be aware of. If you're on a system without systemd, you probably know more than you probably don't need to be watching this video. You probably know all this stuff already. But in any case, so you can run systemctl list units all. This will list all systemd units, whether they're a service or not. So not super useful, but you can grep service, and this will list all actual services on the system, whether they're running, dead, or whatever else. It lists all the services on the system. So that's one, and this would look a little bit neater and cleaner if I zoomed out, but you basically get the idea. So let's clear that out. And if you don't remember these, again, check the link in the description for a document you can use as a nice reference. So in any case, you can use systemctl status nginx to query the nginx service. There you go. Now we see the nginx service. We can see, so systemctl status in the service name. So notice this is nginx.service. You could specify it like .service. This is all service names look like that, but you don't have to. You can omit the .service and just type the name of it. You get systemd, high performance web server and reverse proxy. It's loaded, active and running, and so on and so forth. A bunch of information about the process and stuff like that. So that's good to check if a process is up and running, if it's actually working. The other thing you can do is you can say you can stop a service. So stop it, and it is prompting me for a password. All right, so I'm going to actually cancel that. So realistically, you should be using sudo for this, or just log in as root and run it as root. So sudo to systemctl stop nginx. There we go, we stopped it. So if we check the status, it is inactive or dead, but it's still loaded. Now, if you wanted to disable this, you could disable it so that it won't start on startup. Disable nginx. So if you want to enable it to make sure it starts up on boot and is always running, you can say enable nginx. And if you want to start it back up, make sure it's started, start nginx. If it's already running, you can still say start nginx. Now, so that's how you enable, disable, stop, and start in status. So basically the systemctl commands to basically you put the command right in here. Stop, start, enable, disable, or status. Those are the important ones to remember. And so that's all I'm going to show you for systemctl and systemd servers and services for today. So now let's talk about paths and scripts. So you can, as I showed you before, you can echo out your path variable. Now this is basically a big list. This variable holds a big list of paths, and anything in one of these paths, this is where your system will look for binaries, commands, or scripts that it will run. So say if you type a command like ls, it's going to search all these directories to see if it finds a binary called ls. So for the ls command. Now it's probably in your user bin ls. So user bin is listed up in here somewhere. So in any case, if you put something, have a binary in some custom directory you created, you're going to want to add that directory to your path. So you can export your path temporarily like this. So actually, this is going to be equals. So you're going to export and type the name of the variable equals, then a $sign, the name of the variable. This will represent the current value. So you're going to assign the current value to the new variable that you're creating, and then you're going to add the path that you want to add to it. So colon separates each of these paths. They're colon separated, and you're going to add this new path to your path. So run this. Now when you check your path, it is going to have, opt some software bin. So any binaries or scripts in this directory, you could run them. So say if you had the script called script1, you'd say script1.sh and just run it like that, and it's going to search and find it in this directory, and it's going to work if you had one in that directory. Now vi.bashrc, oops, in your home directory, your bashrc file. So your path is initialized from there. So if you want to permanently update your path, you're going to edit this file. Jump to the bottom here, and notice I have export path $path, and I added the Golang directory right here, and I added some Ruby gems and some other stuff here. So a bunch of stuff that I have in the past added to my path, a bunch of things here I've added to my path. So anytime you want to add things to your path, you can add lines that look like that. So in any case, yeah, you're going to edit your bashrc file, so remember that. Just something to remember if you want to update something like that. So we did exporting the path. All right, so next thing to be aware of, if you have a script, like for example, you go to, I'm not going to show you how scripting works. I'm going to show you how to run scripts and how they work, but I'm not going to show you how to create scripts. This is not a scripting guide. So you can go to, all right, so to run a script, you could specify it by the full path like this, and you could run it. Now, this does not have permission to run. One way you could run a script is by just typing bash, and then the script name, and it will run the script like that, whether you have execute permission or not on that script. So you can, remember, you can chmod something, user plus x, give execute permission for that script. So now you can run the script without specifying bash, and it will just run. And it's going to run in bash by default. So if you were in that directory, you could run the script like this, /, and you could say my script, and run the script like that if you have permission to run it. Now, let's say if you are so let's say if you're somewhere else, like right here, and you say my script.sh, it doesn't know where it is. So it cannot find the command. So if we create a directory like this, so this last directory we added to the path, let's just add this to the path. So there we go. We can add our scripts directory to the path temporarily. And we try to run my script, not going to specify the directory or anything. And there we go. We're able to run it from anywhere. So no matter where we are, so we could be here, we can still run this script without specifying the path for it or anything. Now, if you want to run a Python script, that's another thing I should show you. If you had a Python script called test1.py, you could say Python test1.py, Now, and I guess I do have a script already in this directory called that. So there you go. Now, this could be Python, you could say Python-v, oops. So you could say Python-V, and see this is Python 3, but it could very well have been Python 2. The default on whatever distro you're using may be different, so it may vary. So just pay attention to whether you got Python 2 or Python 3. So in any case, yeah, that's how you could run a Python script. Now let's talk about package management. Now again, this is another one of those instances where check the link in the description for way more info on packages, other distros, how a bunch of other distros that I'm not going to cover here, and how to remove packages, how to do a ton of stuff with packages. I'm just going to show you the basics right here, right now. So first, there's a few commands for Debian and Ubuntu. So if you're on Debian or Ubuntu and you have a physical file, they're .deb files, so a physical package named this, and you want to install it, you can say dpkg-I to install. Using the dpackage tool, you need sudo, so preface everything with sudo, like that. So, unless you're running as root. Now you can also run dpkg-L, you don't need sudo to list the packages. This will list all the packages installed on your system. Now, there's another command, so you can say sudo apt. So normally, instead of dpackage, you're going to use apt to manage packages. So you can say apt update. You normally do this before you install packages or update anything or anything like that. This will pull the latest info about the repository and what packages are available. So you can run sudo apt update. That runs through all this stuff, updates all your meta info on the repos that are available. So that's all fine and good. Now if you want to install something, you can say apt install nginx, for example, and this will attempt to install it. It's already installed, so nothing to do. So you can also search for this package, search for nginx, and you can find all the packages that match the words nginx, and search for the actual package that you want to install if you want to search. So in any case, that works for Debian or Ubuntu systems. Today I'm working on an Ubuntu system. So on RHEL, CentOS, or Fedora, basically any Red Hat based systems, they're generally going to use RPMs. So you can use the RPM command. There's also the yum command, which we're not going to cover here, but check the link in the description for more info on that. But then their big package manager is DNF. So new versions of Fedora and RHEL are going to use DNF. So RPM is the base package tool for installing packages. You can say RPM-QA to show you all packages installed on the system. This is not going to work here because I'm not on a Red Hat system, but that's what you would type. Now, you can type -I and the name of an RPM, like if you have test1.rpm, maybe a vendor distributed this to you or you found it on the internet and it's not in the repositories, so you can install an RPM file on your system manually with the RPM-I. So next we're going to show you DNF. Alright, so if you want to install packages with DNF, like this, DNF install, the name of the package. Now if you don't know the name of the package, you can search with DNF search like this, similar to what we did for Ubuntu with the apt command. So next I'm going to show you Arch. So you can run pacman -S lowercase s nginx. Now this will search for packages with this name. Now if you want to install this package, so if you want to update the package list and then install or upgrade a single package on the machine, you can run at @SYU, and this will do all of that for you. So if you just want to update everything on your entire machine, you can just don't specify the specific package, just pacman-SYU, update your whole system. So that's another thing you can do. on Arch Linux. So anyways, clear this out and let's do a few network commands. So we have the IP command. So anything with the IP command, these are newer. These come with a new package. So they're newer commands. Now on any given system, you may have the newer or the older commands installed, or you may have both. So I'm going to show you both. So IP, the IP command lets you do a lot. You can do IPA or IP adder or IP address. That will show you addresses assigned to interfaces. So you have like Docker 0, Verbridge, or over here, WLAN, that's my Wi-Fi interface. This is my actual Ethernet network interface. It shows you the address for it right here. So that's the IP address. It shows you all kinds of useful stuff. Now, the other thing you can do is you can type L for just links. So A for interfaces with addresses, and you can say IPL just to show you the interfaces. Not sure why that's specifically more useful, or you would want to use that. I just use IPA all the time. And you can also use IPR to show routes. This will show routes on the system, so the routing table with that, right? So the competing command for this was the older command that's deprecated but still available on a lot of systems would be ifconfig. Now, normally you're just going to run ifconfig-a to show all interfaces. This will show all the interfaces. I think the output is a little bit neater on this. Anyways, there's my Wi-Fi interface, virtualization bridge, actual Ethernet, and there's the address. So there you go. ifconfig does the same thing as IPA. Now you can also say route-n. This is an older command that's replaced by IPR. So route-n will give you your routing table and all your routes, right? All your network routes. Kernel IP routing table. So in any case, next I'm going to want to show you how you can see what is listening on different TCP or UDP ports and what the process show you what the PID of the process is, and show you by port numbers. So the newer command, so the new command is SS and the old command is netstat. You can do that with both of these. So SS-LTUPN. So L for all listening ports, T for TCP, U for UDP, P for process, and N for network. So you can list everything there. Anything that's listening on a port here, you see a lot of ports listening. A lot of them are just on your local host. We see DNS right here. And what else? Yeah, a few different things, IPv6 things. So you can see there are a few different things listing on different ports. So yeah, this output would be a little bit neater and nicer if I had zoomed out a little bit in. But yeah, I have the text too large. I'm not going to change that right now. So SS-LTUPN, if you want to see what's listening to what ports, that's super useful to have and a super useful command to be able to use. You might want to use sudo to make sure you can see everything, and that gives us a bit more information on a lot of these. So you can actually get the PIDs. I think the reason I wasn't seeing PIDs before is because I was not using sudo. So remember to use sudo if you want the PIDs for everything. See the PIDs for this process that I'm running, but other people's processes, I can't see the PIDs, what PIDs are listening on what ports. So in any case, that's SS. You use the same command. The old command is netstat. So netstat, same parameters, and it gives you all sorts of stuff here. So you can say sudo to get even more information. Does not look like that's too different. Anyways, so that's the command you would use. Anyways, so clear all that out. Now, check the link in the description for a little bit more info on setting up temporary IP addresses and stuff like that. In this guide, we're not going to show you anything about setting up static IPs or Wi-Fi or any of that stuff. That's something for a whole separate guide. But yes, we're not going to do that. Although in this guide, we do have some info on setting up, bringing up setting an IP address and setting routes and stuff like that. But you are going to just check the link in the description for info on that. I'm not going to actually show you how to do that in this video right at the moment. So yeah, all that is a whole other story for a whole other guide for the most part. So moving along here, I'm going to show you a few more network related commands. So one is telnet. Telnet is used to connect to remote hosts. So you can say telnet and an IP address, and normally that would just telnet into the host. Nobody uses telnet anymore. It's super insecure and really, really old. It was old and insecure and not recommended, 25 years ago when I started with Linux. So now it's even more so. But if you specify a port, you can telnet to that port, and really you're just using that to check if that port is open. And here we see we connected to this, so we can see that that port is open on that IP address. So there you go. That is one way you can do that. Now, a better way to do that would be with the netcat command. So nc, and you could just do nc by itself, but if you want to make sure it doesn't try to send data and it just checks if a port is open, you can do z and v for verbose, and you can check a port on a given host. So let's do the same. Let's do this guy right here. We can check if port 80 is open. And yep, succeeded. So you can also, so the netcat command is a lot nicer than the telnet command. It may not be installed on every system. Usually telnet is. So even today you'll see people using telnet to troubleshoot connectivity to ports. They're not using it to connect to the port. They're not using it as a shell or anything like that, but it's something that's still used today. Now you could use a range. So you could go from 80 to whatever, let's just specify 150. It will check all of these ports and tell you which of them is open. So most of these failed. So let's say if we did 50 to 85. So some of these are going to be open. Oops. Some of these are going to be open, like port 80 is open, port 53 is open, and there you go. That's how you can scan for open ports on a host. Now, if you want to SSH to a host, you can SSH like this. I'm going to show you a real host. So IP. So my current IP address is going to be this guy right here. So I have another host on the same network. So SSH, if you want to SSH into a host, paste I'm going to change this to 2. We can SSH into this host. And notice by default, it uses the current user that you're logged in as. Now, if you want to specify a different user, you could go like this. You could say user 2 at, and it will attempt to SSH as user 2 rather than user 1, since I'm logged in as user 1 right now. Now, normally it's bad practice to SSH as root. Normally you SSH as a regular user and then sudo to root. Any case, you can SSH to an IP address, or you can SSH to a host name, like this host name was Banyan. I could SSH to this, paste, and there you go, SSH in. Now, you can specify the username, like you could say user1 at if you wanted to, or some people, I believe you can actually use a -L. You'll see some people do this. It doesn't make as much sense to me, so don't do that. So that's how you SSH to things. Oh, one other thing I should show you is if you want to use a key file, if you have a default name in your SSH directory. I'm not going to show you how to create those keys today, but if you name it a standard generic name in your SSH directory, you don't even have to specify your SSH key. It's just going to use it by default. But if you have like a strange key you downloaded from Amazon or something, you can specify an exact key that you want to use, like this. Specify the path to the key you want to use, and then just SSH in. So that's how you'd use an SSH key. Now, if you want to SCP is so SSH gets you a shell on the host. SCP is used for transferring files over the SSH protocol. So you can say SCP data1.txt and specify the IP address or host name you want to copy that to. So yeah, you could, for example, use this. paste, and then you're going to specify where you want to copy it to, like home user 1, or you can copy it to var temp, wherever you want to copy it. You basically, the source, destination. Now the source could be a file on your current system, then the host name of the remote system, and the directory you want to place it in. Now, if you want to pull something off the remote system, you're going to have to specify the actual file name, like the file name on the remote system. If you want to pull it off the remote system, you specify the remote system first, and then your say your current directory, like dot, or maybe you want to put it in var log on your current system. That doesn't make sense to do that, but you could do that if you wanted to. That's how you'd SCP something to your current system. So you pull it off of the remote system. So the source is the remote system. You specify the file you want to your current system. Now, if you can also copy things between different hosts. Like, let's say if there was a Banyan2, you say Banyan2 var temp output.log. So you can copy from this host with this path to this host and place it in this path. So even if I'm not even on either of these two hosts, I can SCP files between those two hosts. So then you can, I already showed you, you can specify a username similar to how you can with the SSH command. Same deal, specify a username if you like. So you can also specify, so the other important thing to do is to, so you can specify a key with -i.ssh and whatever key you have, just like that. Same as the SSH command, you can specify a key with the SCP command. Now, another useful thing to do, if you are copying a directory, instead of copying, like if you're from a remote host, if you want to copy this entire directory, or maybe it's like var data1, right? So if you want to copy a directory from a remote host to, say, for example, your current directory, you want to just copy this data directory, the whole directory to where you currently are, you're going to need a -r for recursive. So scp-r, the whatever you want to copy to wherever you want to copy it to. Or you might be copying like something from your local host to the remote host, like that, right? Like that, basically. So you could do that as well, but yeah, that's basically all the important stuff you need to know for the SCP command. So let me actually show you how this works, just to see. So all right, let's say SCP test1.txt to Banyan1 home user 1. So let's just SCP this file. And there you go. It transferred almost instantly because it's a tiny file. We SCP'd that file over to the remote host. Now, next thing I'm going to want to show you is the ping command. So for example, you could say ping google.com if you want to ping it and verify that we have connectivity there. Or you could also run a trace route to Google, and this will basically show you all the hops that it would take to get from my current host to Google. So this is my first router, this is my second router still within my apartment, then this is at my ISP, and then this is another hop, all the way over the internet to Google, wherever their CDN is. In any case, that's how you trace route, and if it fails, if it only makes it to here, or here, you can tell where it's failing and what went wrong and kind of troubleshoot the connectivity. So anyways, host name, the host name command will show you the name of your current host that you are on. Now, a few DNS commands, you can say you have host, nslookup, and dig. So few examples, you can run host google.com. It's going to look up that host name, look up the IP address for it. You can also say NS lookup, and it will tell you like what DNS server it queried, and it'll give you the IP address for it, right? You can also say dig. Dig is a newer recommended tool these days, and it gives you a ton of debug information and interesting stuff. See all the stuff you might be interested in if you wanted it. But yeah, the dig command is also available. Now, you can do all of this stuff. You can also take an IP address. Like let's take this one for example, and paste it in there. You can run host IP address to resolve that to a host name. And yeah, same deal with NS lookup and dig. You can resolve it and get all kinds of extra info too if you want it, right? So that's how you would resolve host names and stuff. Next thing I want to show you is the lsof command. So we're going to run this with sudo just to make sure it shows us everything. We want root permissions. So sudo lsof stands for list open files. Normally you can use this for listing files, but a more useful use for this is to check what is using a certain port on your system. So if we want to check, all right, -I for I guess internet, but that tells us that we're working with ports, either UDP or TCP. You say TCP port 8080. What is using that port? It's not going to tell me because nothing is. But what about port 80? Well, it lists a bunch of processes and their PIDs that are using that, everything that's using that port, and a bunch of information about them. So that is pretty handy to have. You can see what is using a given port on your system. So you could do like TCP 53. You can see what's using that, DNS Masquerade. Now, what else? We could also do UDP. And beyond that, you could if you don't want to specify TCP or UDP, you could just use you could just leave that part out, just colon port 53, and it's going to list the TCP and UDP, so UDP and TCP both. So there's that, and that's basically everything I want to show you about lsof for today. Real handy command to have, and if you want more info on that, check the link in the description for that. But yeah, of course. What else do we have? Next, I wanted to show you a few files that are suitable. Those are all the commands, but I feel like you should be aware of a few files on your system, just some things that you should know. So, cat. So you can cat etc hosts. This is the hosts file. So you see a bunch of hosts, and this is just yeah. So those are just some hosts that they're basically hard coded into that file. So instead of looking them up on DNS, it will just use whatever is listed on that file. So next thing you should be aware of is cat etc resolve. So etcresolve.conf tells you what name server to use. And I'm using something on my current network. That's the host I logged into before. Number 2 right here. Banyan, so that is my DNS server, my DHCP server, and a bunch of other stuff. So yeah, etcresolve.conf. Now, cat etc password is your password file. It basically contains users. Historically, it used to contain passwords, but it does not anymore, so anybody can read that. However, passwords or password hashes are kept in shadow, etc shadow, which we do not have permission to view. You could do that with the root, but I don't want to show that in this video. So, in any case, let's see here. The etc group file. So vi etc group. So the etc group file contains group definitions. So you can see the group and which users are a member of the group. So like ADM, syslog, and user are members of that. I don't know why dial-out exists, but you see all these groups owned by different services on the system. And notice each user has a group for themselves. They have their own groups. And so a user can be in another group as well. So like user 1 is here, user 1 is here. So anyways, good to be aware of. Now next you want to see, let's see, sudoers. So cat etsy sudoers. So you're going to need sudo to view this. This shows you the sudo permissions. So for example, anyone in the sudo group is granted all permissions to log on as any user at all. You can run any command as any user basically using sudo. So if in the Etsy group file you are in the sudo group, which I am, that allows me to run basically any command I want, as long as I use my own password, effectively making me an admin. So there's that. Now the other one you should be aware of is the FS tab, or file system table. At Etsy FS tab. Now this contains basically devices and mount points, basically what's going to be mounted where. So it's a little bit messy here. I am going to make this a little smaller so you can see it a little bit better. Yeah, it's still kind of messy because of how they specify devices. Now you could specify a device like dev SDA, but here we're identifying them by UIDs. That's just how Ubuntu is doing things these days. So a disk with this UUID is going to be mounted on root. File system type is ext4, and here's some mount options and so on. So dump and pass. So yeah, file system, mount point, type, options, dump, and pass. So there you go. You can see where the swap file is mounted, boot EFI, and so on and so forth. So that's the FS tab. Hit that subscribe button. You don't want to miss out on the other great content we have coming up. And we've actually already put a ton of great content out so far. So check the playlist. I've gone into detail and done like deep dives on most of these commands I've covered today, and the ones that I haven't, I'm going to be doing more deep dives on. So stay tuned for that. Check the playlist. Check some of our other playlists too. We have a lot of great content already published, and we have a lot more stuff coming out. So make sure you hit that subscribe button. Also hit the bell icon so YouTube actually notifies you when we do come out with new stuff. And yeah, definitely, we cover a ton of other great tech stuff too. We're doing a lot of Linux stuff, but we still touch on things like Windows. We're doing a lot of coding, scripting, automation, data engineering stuff. We're going to be doing some data engineering stuff. We do like electronics, building robots, Raspberry Pis, 3D printing, just a lot of great tech stuff that's going to make your YouTube feed better. So definitely hit the subscribe button so you don't miss out on all of that stuff. And if you know something I don't know, or if you missed something, or you feel like I should have included something in this guide, leave a comment down below. I want to know what you think, and maybe if I were to redo this guide, how would I do it differently? If I do redo this guide, what type of things would you like to see, and what types of things would you not like to see in a newer version of this guide? Let me know down in the comments, and I will probably be taking that stuff into consideration. And if I were to put out an advanced guide, what type of stuff would you like to see in that? If you want me to deep dive on any Linux topics or any other topics, definitely leave a comment down below so I know what types of things people are interested in and what kind of content people want to see. And that's about it for today. So as always, thanks for watching, and we'll see you guys on that next video.